Hello everyone, welcome back to another session. So I hope you're all doing well. This is Ripanjeet welcoming you to this session. So do you remember what we did in the previous session? If not, let me remind you once. So here it is. How to locate root 7.5 on the number line, or for that matter, how to represent any number on the number line which is an irrational number and the proof for it as well. Do you think you can plot this on the number line? If yes, what is the way? Let us look into this a little. See, we have to plot 2.7564 on the number line. What do you think? What are the two numbers on this number line where 2.7564 is going to come? Here we can see the number is 2.7. That means it is bigger than 2, right? So bigger than this 2. Bigger than 2. And do you think it will be greater than 3? No, right? So this number is lying between 2 and 3. 2 and 3, right? So we are checking only first two numbers first. 2.7. It is lying between 2 and 3. Okay, now we know this. So we put over here a 2, and after 2, 2.1 there comes 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, finally comes 3, right? So we have found 2.7 over here, 2.7 here, right? So we know where is 2.7, but they are not stopping here up till 2.7. The number is 2.7, and let us take just one more. 2.75. That means the number is lying between 2.7 and the next digit. What is the next digit after 2.7? It's 2.8, right? So 2.7, 2.8. So the number would be lying between 2.7 and 2.8. Let us plot this as well. So we will start with 2.7 here, and at the end there will be 2.8. And in between, what is it going to be? Yes, in between there is going to be 2.71, 2.72. So these are all the numbers that will be between 2.7 and 2.8. Now we want to locate 2.75. So where is 2.75? We can locate, it is here. And what was the original number? Original number was 2.7564. 2.7564, correct? Now we have located 2.75, but there is after 6 also, right? So that means the number is bigger than 2.75, and the next number is 2.76. So we are going to again plot 2.75 and 2.76. So what are the numbers that are going to be there in between it? 2.751, 2.752, 2.753. So these are all the numbers that are going to be in between 2.75 and 2.76. Okay, we got this. Now here we located 2.75, right? And now the number is 2.75. 2.75 we have found here. 2.756 we have to find here. 2.756. So here it is. 2.756. And the next number is 2.757. So the numbers are lying in between it. So let us see it again. What are the numbers that are going to be here in between 2.756 and 2.757, right? Okay, hopefully we will be able to locate it right now in this itself. So let us see next. It is the next number here. It will be 2.7561, 2.7562. So these are all the numbers between 2.756 and 2.757, right? So we want to locate the number 2.7564. 2.7564. Okay, so let us see where is it. Okay, finally, can you see it here? Over here, 2.7564. So this is how we can locate the numbers which are so tiny, right? They're all existing on the same number line, right? Okay, so after this, what do you think? Can you locate 5.73 and what is over that? 5.73. There is something like this. Have you ever seen this? Well, this thing is called as bar. Bar. What does this bar mean? Whenever there is a bar on the number, it means that number is repeating. 5.73333 and so on. So if the number is repeating so many times, do you think you'll be able to plot it till the exact point? No, right? So what is the way if some question like this is given? Well, there is a way, and that way is representing it like this. That's saying locate this number on the number line up to 4 decimal places, up to 5 decimal places, up to 7 decimal places, right? So that means if we are told that locate it up to 4 decimal places, that means we have to do 5.7333. 4 places are done, that's all. 6 decimal places, then add 2 3s more, right? Now this bar was only on single number. What if the question is this? How many numbers are repeated? Well, bar is on 2 numbers, so it is 4.21, 21, 21, 21, and so on it is going. So 21 is a repeating number. Okay, what if 0.43652 and the bar is on these 4 numbers? Yes, so we are going to repeat these 4 numbers. So the repeated version would be 0.43652, 3652, 3652, and so on. So now we know the numbers can be repeating, and to provide a shorter form, we represent the repeated numbers with a bar, right? Now we know that. Okay, great. All right. So see, till today we have seen so many type of numbers, right? We started with simple ones, 1, 2, 3, and so on, natural numbers. And when we add a 0 to it, it becomes, yes, a whole number. And what if we are adding even the negative numbers, -1, -2, and so on, it becomes integers. And what if we were adding even the numbers which are fractions, yes, 2/7, 3/5, -8/6, right? They become rational numbers, right? So these all things are coming under rational numbers, right? Rational numbers are containing all the type of numbers. Okay, if I say 3 is a rational number, how can we write 3 is equals to 3/1? Isn't it rational? Is 0 a rational number? Can we say 0/9? Isn't it rational? So see, all the numbers, all of these whole numbers, natural numbers, integers, and are coming under rational numbers, right? And there were another type of numbers which were irrational numbers. √2, √7, √50, let us say 9, right? All of these are irrational numbers. So these are rational, represented with a Q, right? And there are irrational, represented with I, right? And these all were coming under what thing? Yes, coming under set of reals, real numbers, represented with R. Okay, so now we know this. After this, how can we identify that a number is a rational number or an irrational number? How? For example, for rational numbers, what is the way is the remainder becomes 0. It can be the first case, right? the remainder becomes 0. Right? For example, if we have 3 over 2, how did we get 3 over 2? 3 divided with 2. 2 ones are 2. 1 is left. We put a point and then a 0 over here. Take down the 0. 2 5s are 10. So the remainder becomes 0. This is the first case. Now what is the second case? Well, the second case is we have 1 over 3. Or let us say 10 over 3. Becomes easy. If we divide 10 with 3, well, 3 3s are 9. 1 is left. We put a point over here. We put a point over here, 0. Right? And then we take down this 0. 10 again becomes 3. Then again 9. 1 is left. Take down 0. Again goes on 3. 9. And then again 1 become 10. And it is also again going to go on 3. So, so it is going to go on 3.3, 3, 3 and so many 3s, right? Can we represent it like this? Yes, very good. See, the bar is always placed after the decimal point, not before the decimal point. Remember this, right? So, the thing is that the decimal representation, it starts repeating. So, what is the second indication for a rational number? Well, the digits starts repeating and endless, not ending. So we call that as non-terminating. Non-terminating. Do you remember we did this in the first session? So these are the two indications of the rational numbers. Either the remainder will become 0 at the end, and number 2, the digits will start repeating and they will be non-terminating. They are not going to end, right? And then let us see what is it that tell us that the decimal representation is an irrational number. It is of an irrational number. So the indication is very small and single, that number 1 is the same. Digits are non-terminating. Digits are not just non-terminating, but they are also and non-repeating. They're also not repeating. Go on and on and on and on. And if the decimal expansion or the decimal representation given is a rational number or an irrational number. If the remainder is 0, digit starts repeating or the word used is reoccurring. Do you think there is a way that we can find out how we can change a decimal representation into a rational number? Do you think that is possible?
So today we learned how to plot this number on the number line. After that, what does bar mean, how we can write the bar numbers, and after that, reals are either rationals or irrational numbers, right? Reals are rationals or irrational. Rational mean when the remainder is 0, digits are repeating, non-terminating, and in irrationals, non-terminating and non-repeating numbers are there. Right?
My last question to you is, see, I am writing 1.27 bar, which means 1.272727 and so on. So many 27s are there. Can you bring it to the form of a rational number, which is P over Q? Is it possible to make it come into the form of P over Q? Well, think about it, find out a way, and we are going to see this in our next session. So till then, take care. Bye.